Okie dokie. We're going to be today thinking about a topic that is sort of the opposite of GCF. GCF is greatest common factor. What we're going to be talking about today is what is called the least common multiple. Now, before I explain what that is, let's think about what each word means. LCM stands for least. And we're on page 5, by the way. I'm sorry. Page 5 of the Unit 4 packet. We're going to be talking today about the least common multiple. Okay? So least, what does least mean? Well, least means it has the lowest value. Lowest value. If something's the least, it has the lowest value. What common means, it's shared. It's shared between two or more things or numbers or people. So if they have something in common, it means that they're shared. Now a multiple is if you count by twos, the multiples are 2, 4, 6, 8. It's a number you can get to by multiplying. So it is a number you can get to by multiplying. Also, multiples of a number, if you divide a multiple by that number, you don't get a remainder. So like 8 is a multiple of 2. If you count by twos, you can get to 8. 2, 4, 6, 8. 8 is a multiple of 2. So it's 10 and 12 and 14 and 16 and 18. So what we're doing is we're going to be finding the number that has the lowest value that is shared by two numbers when you count by those numbers, or to find the two multiples or the multiples of that number. So we're going to start out with some easy ones here. But right below where it says least, I want you to write the word list, because that's the method we're going to use this year to find the least common multiple. We're going to list common multiples. We're going to list. So method 1, the only method we're really going to use this year, is using an organized list. So we're going to find the least common multiple of 2 and 3. So this is what we're going to do. We're going to count by twos, we're going to count by threes, and we're going to see what is the least common multiple they have. What is the first one that comes up that they both share? So let's count by twos. 2, 4, 6, 8, 10. I'm going to go up to 12. Okay, I might have to go further, but I'm going to go up to 12. Now I'm going to count by threes. 3, 6, 9, 12. Well, would you look at that? They have multiples in common. 6 is in common, and 12 is in common. Well, we want to find the least common. The least common multiple would be 6. That is the least number that they have in common that is a multiple. So 6 is the LCM of 2 and 3. When we count by twos, when we count by threes, 6 is the first number we get to that they have in common. All right, we're going to try another one here. Find the least common multiple of 6 and 10. So we're going to count by 6s, we're going to count by 10s, we're going to see what happens. So 6, start with 6 and then 12, then 18, 6 times 4 would be 24, and then 30. I'm thinking that's a multiple of 10 as well. But let me check. So I'm going to stop here. I'm feeling good about 30. So let's count by 10s. 10, 20, 30. There it is. So they have no other multiples in common at this point. We could keep counting, but we want to find the least common multiple that would be the least common multiple. So 30 is the least common multiple of 6 and 10. So if we kept counting by 6 and 10, The next multiple would be 60, and then 90, and then 120, but we can go on and on forever. This 30, though, is the least common multiple they have. All right, at this point, if you want to try some on your own, if you're getting the hang of it, you can try the next one here. If not, you can do this next one with me. So every time I set these up to make a list to find the common multiples, I first write the number and then put a little colon here that tells me I'm going to make a list. 9, colon, I'm going to make a list here. All right, let's count by sixes. So 6, and then 12, and then 18, and then 24. I'm going to stop here. I'm thinking 18 might be it. So let's count by nines. 9. The next multiple would be 18. Voila, we got it. So 18 would be the least common multiple of 6 and 9. So 18 is the LCM of 6 and 9. Perfect. Okay. So again, if you want to try this next one on your own, you can. You just got to be really careful with this because you want to make sure that as you're finding the multiples, you are going up by the right amount. So if I were to go from like 6 to 12 to, let's say, like 17, then my answer is going to be thrown off completely. So you got to make sure that when you're counting on, you're doing it really accurately so that you arrive at the right number. All right, so we're going to find the LCM, the least common multiple of 15 and 12. Let's try it. Here. So I'm going to count by 15s first. Let's see what happens. 15 will be the first number. Then 30, 45. I think after that, 45 plus 5 would be 50, and then 10 would be 60. Then 75 would be the next one. So let me count by 12s now, see if any of those numbers come up. So 12, 24, 36, nothing so far. 48. Now you got to be careful here because I remember in the past, like a lot of people would say, oh, the next one's 50. But that would only be adding 2. 48 plus 2 is 50, but we have to add 12. So 48 plus 2 is 50. 48 plus 12 would be another 10. That would be 60. Hey, we got it. 60, when you count by 15, you count by 12. 60 is the first number you get to they have in common. So 60 is the LCM, least common multiple, of 15 and 12. There you go. All right, now the two below are a little different because they're asking us to find the least common multiple of 3 numbers. So again, we're going to set this up the same way. We're going to use the same method. We're going to use a list. We're going to list the multiples to find the least common multiple. So let's do 4, 5, and 10. All right, let's see what happens. I'm going to count by tens. Actually. I'm going to count by the higher number, the greater number, because that will help me find the multiple maybe a little bit more quickly. So if I count by tens, 10, well, 5 goes into 10. 10's a multiple of 5, but 10's not a multiple of 4, so I'm going to keep counting. 20. 20 is a multiple of 5. And if I count by 4s, I also get to 20. So I'm thinking it's 20. Let's see here. If we count by 5s, it'd be 5, 10, 15, 20. Feeling good. If I count by 4s, it'd be 4, 8, 12, 16, and 20. Now you can see here they have 5 and 10 share a 10, but 4 doesn't also have the 10. So we're looking for the number they all have in common. The least common multiple of all 3 of them would be 20. So we'd say 20 is the LCM of 4, 5, and 10. So before we try the last one on this page, I just want to explain this. So Least common multiple, we're using a completely different strategy from GCF. This is completely different. I know they both have like 3 letters. One's GCF, one's LCM. So that's why it's important to understand like what each of them mean, because to find the GCF or LCM, you used a completely different strategy. So that's why when I think of least common multiple, I think of listing, list, least, list multiples. That will help me remember to list numbers. GCF, we're going to use the factor trees or the prime factorization. So 2 completely different methods. These are 2 completely different ideas here. Just want to clarify that. Find the least common multiple of 4, 6, and 15. 4, 6, and 15. 4, 6. So we're going to look for the common multiple between all 3 numbers. All right, I'm going to count by 15 first, because maybe I'll find the multiple even quicker. 15 is the first number. If I count by 15s, I'll get to 30 next. Now, if I count by 6, I'll get to 30. But if I count by 4, let me see if 30 works. 6, 12, 18. Next one would be 24. Then 30. Oh, feeling good about 30. Feeling good about 30. And then 4 would be 4, 8, 12. You see 12 is shared, but not all 3 of them. 16, 20, 24. Another shared one here, but 15 doesn't have 24. 28. Uh-oh. So 30 is not going to work. 30 is not going to work. All right, let's keep going here. 15, 45. And I think we've counted by 15s. If you look at the one above it, we already counted by 15. So that's going to be 60. Well, 60 definitely for 6 would work. Maybe 4 too. So let's count by 6s to see if we get to 60. We should be able to. 36, 42, 48, 54, and 60. Now moving on to the 4s. I'm thinking 4 might work for 60. Let's see. Because I know 4 goes into 20. If we get to 20, we get to 40. If we get to 40, we get to 60. So 32, 36, 40, 44. I'm going to have to start a new row here. Got up to 44. I'm going to start a new row here. I'm just going to make a little line here. 48. Yeah. 52. Okay. 56 and 60. That's why it's really, really important that we count when we count these multiples that we're doing it accurately. Because if I got to like 51 here instead of 52, I wouldn't wind up getting the 60. So when we counted on by 4s, 6s, and 15s, we got to 60. That means 60 got to 60 first. 60 is the least common multiple of 4, 6, and 15. So that one we had to count quite a bit. The other ones actually we got to pretty quickly. This one we had to count on a little bit more. Sometimes when you do 3 numbers instead of just 2, you may have to count longer. But for the most part, we're going to be working with 2 numbers instead of 3, so that'll be nice. All right, let's check out the next page here. We're going to do a three word problems here related to least common multiple. And what's going to be important here is to think about like what is the common feature of all of these problems. So we have up top, we have Ernesto has painting class every 8 weeks. Nice. Kamala has pottery class every 10 weeks. Ernesto and Kamala met at the art building for class this week. How many weeks will it be until they meet each other again? How much longer will it take until they meet each other again? This might be a clue that this will be a least common multiple problem. Okay, so we have Ernesto, we have Kamala. Ernesto's every 8, every 10. So what we're going to do is we're going to count on until they have a common number, a common multiple. So Ernesto goes to class every 8 weeks. That's going to be 8, and then 16. The 16th week he'll be there. And then the 24th week, he'll be there. And then 32nd week, he'll be there. And then the 40th week. I'm feeling good about that 40 because I know if I count by 10s, I'll get to 40. So let's just show that here. 10, 20, 30, 40. The lights turned off again. Just go turn them on real quick. Sorry for the delay. Apologize. All right, so that means that after 40 weeks, they'll see each other again. So if you notice, like, Ernesto would be there 8 weeks after. Kamala, 10 weeks. Then 16, she'll be there 20. So they're like not meeting up here. They're there on different weeks until the 40th week. The 40th week, they will see each other again. So they will see each other again in 40 weeks. So this is a sign of when you'd use least common multiple. Is when you're trying to find like when are two things going to happen together again. That's a least common multiple problem. So we'll see a couple more like that, and we'll try to pick out some of those common features. All right, it says at the fair. This next one says at the fair, there are two Ferris wheels, a large one and a small one. The large Ferris wheel takes 16 minutes to spin all the way around. I'm just going to jot that down, 16 minutes. The small one takes 12 minutes. I'm going to write that down, 12 minutes to spin all the way around. If both Ferris wheels start spinning at 1 p.m., at what time will they be back in the original position? Okay, so we have a large and we got a small. This is the clue here. What time will they be back in their original position? When are they going to be back again in that same spot? That is an indicator of a least common multiple problem. When are they going to be back again? All right, so the large Ferris wheel spins every 16, small one every 12. All right, I'm going to count by 16s. Let's see what we get to. 16, well, that's not the answer because if you count by 12s, you're not going to get to 16. 16 times 2, if you double that, you get to 32. If you count by 12s, I don't think you get to 32. If you add another 16 on, that is going to be 48. And I'm thinking that might work with 12. So 12, 24, 36, 48. There it is. So what happens is like the large one will spin once, twice, 3 times, whereas the small one will spin once, twice, 3 times, 4 times to get back to their original position. So after 48 minutes, they will be back together at the start. Okay? So it says what time? It'll take them 48 minutes. So if they started spinning at 1 o'clock, they'll be back together again at 1:48 p.m. They will be back. Can't see that. In the original position. They will be back in the original position at 1:48 p.m. Nice. So again, when you're looking to see whether it's a least common multiple problem or a question, you're thinking like, what does the question say? Does it tell me like when is something, is it asking me to find like when something's going to happen again, or when are two things going to be back together again or back in the same position again? That's an indicator of a least common multiple problem. All right, this next problem is inspired by a movie called Father of the Bride. There's a famous scene where a character named George Banks goes to buy hot dog buns and hot dogs, and he finds out that he can't necessarily buy the same number of both with just one package, and he gets very upset. All right, so we're looking at this problem to see if there's when will they get back together again? When will something happen at the same time again? Let's see if we find it here. George Banks, who's the name of the character, went to the supermarket to get hot dogs and hot dog buns. The hot dogs were sold in packages of 6. The hot The buns were sold in packages of 14. How many hot dogs and buns would he have to buy so he has the same amount of both? So this is slightly different, but to find the same amount of both, that reminds me of the Ferris wheel problem. When are they be back together again? That reminds me of the Ernesto one. When are they going to see each other again? When are they going to have the same amount of both? When's the number going to be the same? All right, so we got hot dogs. We got hot dogs, and we got the buns. We can buy hot dogs in packages of 6, buns in packages of 14. All right, let's count by 14. Sometimes counting by the greater number might help. So 14, and then it would be 28. So to add on 14, 28 plus 4 would be 32, and then add a 10 would be 42. I'm thinking that might be it. Let me check 42 with 6s. You got 6, you got 12, and then 18, and then 24. 24 plus 6 is 30, 36, and believe it or not, 42. So George would have to buy 42 hot dogs and buns to have the same number of both. Whoops. So that's a lot. It's going to have to buy a lot. So, I mean, if you look at this, like you have to buy 1, 2, 3, 4, 5, 6, 7 packages of hot dogs and 3 packages of buns. Then he'll have 42 of each, which will work out really, really nicely for his barbecue, whatever he's doing with them. All right. If you have any questions, let me know. Hope you enjoyed least common multiple. We'll be using it more this unit. All right. Have a great day. Bye-bye.